During this lesson, we're just going to be calculating impulse using P equals M change in V, and we're going to talk about the force bit later. But we're still going to use the actual units of Newton seconds. Now, I've got down, like just down the bottom here, I've said here there's something strange about the units for momentum and impulse. So impulse and momentum are basically the same thing. Momentum is just a change. Sorry, impulse is just a change in momentum. I guess the one you could think about that's similar to this is energy and work. So work is a change in energy. Impulse is a change in momentum. We know work and energy have the same units. Why don't momentum and impulse have the same units? So momentum has those weird units, kilogram, meters per second, whereas impulse has Newton seconds. So why are we doing this? What's the deal? Well, they're dimensionally equivalent, which means that like you can actually resolve this. And if you're looking for something to do, it's a pretty fun one to do. It's a fun physics thing to do. You can actually have a go at it for me. Just see if I'll mail you out a scratch and sniff if you can work out how to basically change kilogram meters per second into Newton seconds. There you go, it's a challenge. Okay, so they're the same thing, but we use Newton seconds for impulse, and that's because we're generally dealing with like a force on an object. So we're thinking about one object and the force, whereas the other one we're thinking about like the velocity of objects. So it makes more sense to have it kilogram meters per second, which is velocity. Okay, so how do we calculate impulse? It's really simple. So I've got an example here, and there's another one on the next page that I'm going to get you to try yourself, but I'm going to lead you through this one first, and then you're going to have a go at the second one yourself, and then the slide after that, you'll find a work solution for it. Okay, so basically we've got a mass here. It's a 5 kilo mass. Its initial velocity is 10 meters per second, and its final velocity is 0 meters per second. So our impulse, we can see down here, I've got an equation, I equals change in P, which equals M change in V. So we're just going to times the mass by the change in velocity. So we've got 5 times 0 minus 10, and we end up with minus 15 Newton seconds. So therefore that impulse is acting in the direction opposite to that initial velocity, hence the negative. So you could also write this as 50 Newton seconds in the direction opposite to the initial velocity. That would be fine as well, but you have to remember that you do need units for this. Not units, sorry, you need direction. You need units and direction.